Hexadecimal, or hex for short, is a base 16 number system. It uses 16 symbols, the numbers 0 to 9, as well as the letters A to F. It is based on powers of 16. If we follow the same procedure used for converting binary to decimal, we can write out the place values or positional notation for the hexadecimal number system as well. Here we can see the first 4 place values based on powers of 16. This is 16 to the power of 0 or 1. Any number to the power of 0 is 1. This is 16 to the power of 1 or 16. This is 16 to the power of 2 or 16 times 16, which equals 256. And this is 16 to the power of 3 or 16 times 16 times 16, which equals 4096. Let's look at the decimal and binary equivalents of each hex symbol. These are the decimal equivalents. Note that the hex symbol A is equal to decimal 10, hex B is equal to decimal 11, and so on until we get to hex F, which is equal to decimal 15. Here are the binary equivalents. Note that each hex symbol can be used to represent a 4-bit binary number. Given that 8 bits is a common binary grouping, we can represent an 8-bit binary number using just 2 hex symbols. In this first example, let's look at converting hex 2A to decimal. First, I'll write out the positional notation for the first 2 powers of 16, then insert the hex symbols below the corresponding place values, 2 under 16 and A under 1. Then I'll multiply each hex symbol by the place value that it's under and add the results together. So we get 2 times 16 plus A times 1. That gives us 2 times 16 plus 10, which is the decimal equivalent of A in hex, times 1, which gives us 32 plus 10, or 42 in decimal. Multiplying or dividing by 16 isn't always easy when doing hex to decimal conversions. Usually it's easier to convert the hexadecimal or decimal value to binary first, then convert the binary number to decimal or hexadecimal. Let's convert decimal 197 to hex. First, I'll begin by converting 197 to an 8-bit binary number. Here I've drawn out the first 8 place values of the binary number system. We need to find out what combination of these place values adds up to 197. I'll begin by writing 197 on the left side, and starting at the left, if the place value is equal to or less than this number, I'll put a 1 under it and subtract it, and if it's greater, I'll put a 0 under it and move to the next place value. So 97, I'll put a 1 under it and subtract it, and that gives me 69. I can subtract 64 from 69, so I'll place a 1 under that and subtract it. That gives me 5. 32 is too big, so I'll place a 0 under that. 16 is also too big, so that gets a 0. 8 is also too big. But when I get to 4, I can subtract that, so I put a 1 there, and I subtract it here. 2 is too much, so a 0 goes there, and 1 is just right, so I subtract it, and it results in a 0. Therefore, decimal 197 equals binary 11000101. Next, I'll convert the 8-bit binary number to decimal by first splitting it into 2 4-bit binary numbers, and then I'll rewrite the first 4 binary place values above each half. So here I have 1, 2, 4, 8, and then repeat it on the left, 1, 2, 4, 8. Then I'll convert each half to decimal, and then each decimal to its equivalent hex value. On the left side, we get 8 plus 4, which equals 12. And on the right side, we get 4 plus 1, which equals 5. If we convert those to hex, 12 decimal is the equivalent of C in hex, and 5 decimal is the equivalent of 5 in hex. Therefore, 197 in decimal is C5 in hex, or it can also be written with a 0x preceding it to indicate that what follows is written in hexadecimal. Lastly, let's look at converting from hex to decimal, but this time we'll convert to binary first instead of going straight to decimal like I did in the first example. I'll convert the hex 9F to decimal. First, convert each hex symbol to its 4-bit binary equivalent. I have hex 9, which is the same as decimal 9, and that gives me 1001. And then I have hex F, which is equivalent to decimal 15, and that gives me 1111 in binary. Next, I'll combine them into one 8-bit binary number. So here I have the first 8 place values in binary, and then I'll convert to decimal, and that gives me 128 plus 16 plus 8 plus 4 plus 2 plus 1, or 159 in decimal. There are often several ways to approach converting between number systems. Use you.